Hello champions, this is Precious Iriao again from Click8 Academy, and I'm very delighted to start this phase with you considering that we've been able to come this far. This is C programming and this is our very first low-level programming language, and I'm delighted to walk this path with you. So let's begin. C programming. Introduction to C. So what is C exactly? C is a programming language, simply as that. C was created by Dennis Ritchie at the AT&T Bell's Laboratories in 1972. It was supposed to be a successor to another programming language called B. Is that not interesting? So you wish there was a D programming language, right? Also, it is what we call a low-level language. This is because there is only little abstraction between C and the machine language. That is, there is just a little bit of difference between what you have in C and the way the machine understands the language. So that is why it is considered to be closer to the machine's hardware. So you see, if you can understand the C language, it means that you are actually speaking in machine language. Is that not cool? Now, C is also a compiled language. That is to say, it is not interpreted. Compiled in the sense that when you write your codes in C, you have to compile it for it to be executable so that the machine can read it. Let's go again. When you write your program in C, your machine does not understand it. You are the only one who understands the instruction. So you have to compile it. Now, when you compile it, that is when your machine can understand it. So you are speaking to the machine indirectly. Also, C is not object-oriented, and this is where it differs from C++. And if you are wondering what is C++, C++ is also a programming language, but it is an extension of the C programming language. So if you understand C, then you would understand C++. That is fun, isn't it? Now, for us to begin our C programming language life, we have to get some tools ready. So, you need to have access to the shell, okay? The shell is a program that takes commands from your keyboard and gives them to the operating system. We all know what the shell is at this stage. So, for us to be able to do this, the first thing we need is a terminal. So I know you've been able to install a lot of terminals. Maybe you might have yours with Ubuntu, on Windows, or through VirtualBox. The point is, have a terminal. Like in this video, I'm going to be using command prompts, and I'll use that to access my Linux distribution, Ubuntu. Also, you have to understand the command line commands like ls, cd, etc. So you know what ls is, list contents, cd means change directory. If you want to understand more about this, then you have to check my previous videos, or you make a request for me in the groups or in the forum or anywhere. Also, we need a text editor, and like you know already, my favorite text editor is the VRM editor, and you can use Emacs for those who love Emacs. We also have Nano and the rest of them, but I will use Vim in this video. And also, we need a compiler. So a compiler is what changes your code to what the computer can understand, and the common one we know or we would use is called GCC, and GCC stands for GNU Compiler Collection. This video, I'm not going to show you how to install this. I believe you should have done this. Your computer should have GCC, and if not, check my previous videos or make a request in the forums, in the groups, or anywhere, and I would respond to you. So now that we know what we need, what is the next step? The next step for us is to write our first simple C program. So let's begin. First, I'm going to start up my my terminal, okay? So let's get to it. So I'm going to be using command prompt like I told you, and I'm going to open it right here, Windows Terminal. And this is my command prompt open on your screen. And for me to go into my Linux distribution, all I need to do is say bash, okay? Bash me in. And guys, I'm in Linux now. So previously I was in Windows, and now I'm in Linux. But it's not nice for you to work in this directory. So anytime you open your Linux distribution, ensure you always do this: cd So this takes you to the home of your Linux distribution. So you don't just do stuff anywhere on your computer. It takes you to the home of your Linux distribution. So let me clear the screen, or let me do an LX so that you see that I'm here truly, you see. And if I do a PWD, you see I'm home. I'm home. Precious is home. So let's clear and let's begin. So I told you previously you need a terminal. This is it. And you need GCC. So let's confirm if I have GCC installed. And yes, I do have GCC installed. So if you've not installed GCC, you have to find a way to install it. I'm not going to show you how to install GCC in this video. So, like we said, what are we doing? We are going to write our first C program, and it's going to be hello world. Okay? So let's do that. The very first thing we will do is, let's create a folder to store all our C programs. So I'm going to create a directory called mkdro. I'll call it C learning. Okay, and I'm going to go into it. So I'm inside of C learning now, and this is where we are going to do all of our programming. So now that we are in C learning, as you can see, there is no content. So let me clear this. Now, to create your very first program, you need to create a file that ends with the extension .c. So I will say touch. Let's call this file what? Let's call it hello. Okay, but not just hello, but hello.c. And congratulations if you've done this step with me. This is your very first C language. Now let's write content into it. So I'm going to open this with my favorite editor, the Vim editor, and let's begin. So now I've been able to open the file in my editor, and I'm going to start by writing some commands. Please, if you don't know what I'm doing, don't worry, I'm going to explain it, but let me just do everything properly first so that we can go. So the first thing first is I'll start with the preprocessor. So include, so I'm going to include the header for the standard input and output, stdio.h. Okay. Now, the next thing I will do is I will create a series of comments. Okay. So I will say main. I will just call this entry point, or main. Don't worry, you don't need to know what is happening here. I will explain everything. Return. So I will say returns 0 if successful. So this is a comment, okay? This is a comment, but I would explain it again. Now, let's create our first function. So int main. So the function we are creating is called main. And I would open a bracket. You can leave it empty, or you can write void inside of it. Okay, let's leave that. We'll come back to this. Then your first curly brace. Then you close the curly brace. Then inside of your function, you return 0. So this is the skeleton of a simple C program, okay? But now let's do something. Let's let it do something. So I will say let's print what? Hello world. And always end your statements with a semicolon. So this is a simple C program, and now we can save this file. So let me just do a recap of what I've done here before I run it. Let me take you to our script, our presentation again. So in our presentation, you can see the simple C program. So we have the include, which is the preprocessor directive. to find the header file. And which header file is it looking for? It's looking for the stdio.h, that is standard input and output header file for library function. Then we have the comment, the one we created, and the short comment. We are also going to create this now. Then we have the int and void. Okay, so let's do that. So let's say this is a short comment. So it say prints hello world. Okay, so we are telling you that this function is going to print hello world. This is a comment, it's not going to show in our program. And also we want this to be on a new line, so /n, all right, like we have here. So the main function, so execution in your C program always starts with your main function, okay, and it ends there. It doesn't matter where the main function is, and you must put the main function in every program. Then you have your new line character that moves your cursor to the new next line. Then also return 0 means that your program has run successfully, so it's going to return 0. So let's go to the program, let's look at it, let's break it down. Here we have the include. Like I said, the include is the preprocessor directive, and it tells the file, or it tells C to look for the file and place the content in that location. So it does some preparation before your code is compiled. Then standard input and output, this is an header file. This helps to perform input and output operation for C programs. In short, it is because of this that is why we can use the printf. Without this, we won't be able to use printf, because you know printf is for output and this header file is for output. Then you see the angle bracket. The angle bracket is telling C to look in another folder instead of the current folder. If we put this in double quotes, the C is going to look for it inside of this folder, but naturally we would always use angle brackets. So that is why you have include standard input.output first before anything. Now the next thing you have is your comment. So this comment here is very important because it tells someone that is looking at your program for the first time that you have your main function and you also have the return. So we can put other information inside of this comment, and it's not going to be executed with our script. Then the next thing we have is the first function here. It has a data type of int, and the function name is main, and it has the parameter of void. What does this mean? This means that this function int is going to return an integer, that is this 0 here. So this function is returning a value, is returning 0, but it is not taking an argument because it is void. We can even delete void and leave it as empty, okay, so that you know that it's not taking anything. You can also run it like this, okay. And every C program must have this. It can be anywhere, but your program execution is going to start with this main function and is going to end with this main function. Everything you are going to run in the C program will be inside of the main function. The next one we have is the printf. This is a function that comes from this standard input.output header, and we can use it to print information to the stream, to the output stream, that is our terminal. So in this one we are printing hello world and we are pushing it to a new line. And this is a short comment that tells you what this function is going to print, hello world, okay. And finally we have the return statement that tells you what this function is going to return after you run it. It is going to return 0 to tell you that it ran successfully. So guys, let's try this out. So I'm going to save this now, and I'm going to exit out of it, okay. Then for me to be able to run this function, remember we said previously that for you to run a C program you have to compile it. So this is where your GCC comes in. Now we have to compile this program, so we say GCC hello.c, and if we do this, what happens? The program has been compiled successfully. Let's check what we have inside of our folder now. So I will do an ls. As you can see, previously we had our hello.c program that we wrote into, and after compiling with gcc hello.c, we now have a new file called a.output. We did not create it, okay? GCC created it, and this is what the computer will understand. So let's run that. To run a program in shell or in your terminal, you use /, that is check in this folder, then a.out, that is the folder, the file name. So if we do this now, what is it going to print out? I hope you guessed that right. And you see, we have our hello world. So congratulations, guys. You just ran your first C program. So I would say that you should clap for yourself right now. Now that we've done this, the next thing we need to understand is how does C program does the compilation of this file. How did it compile this file to a.out, and what can we do to change how it compiles our files? So this takes us to the next one, and here we have what we call compilation. So we are in compilation, but before we proceed, I want to show you something else. I left this behind, so I want to know that you're following the video, and it's a new statement called the exit statement. So what does exit does? Exit jumps out of the execution or the program. So let's see exit in action. Okay, you can use exit with the return statement. So let's go back to our editor and let's edit our hello.c program. Okay, hello.c, and I want to show you something. So let's assume that I want to add another printf statement. Okay, so I'm going to add the new printf statement just right here, and I'm going to say printf hello, I love C programming. Okay, so let's put the new line character, let's close it, and let's stop the statement. So like you know already, this is going to print out two statements on our screen. All right, so let's compile this. GCC hello.c is going to overwrite the previous one, so now we can call it again. So /a.out, and you can see hello world, I love C programming. Now how do we use the exit statement? Let's go back to edit our file. To use the exit statement, you use it assuming you have a statement or a line of code you don't want to run anymore. That is, you want to jump out of execution. Remember previously when our code ran, it ran both printf statements, but we can make it stop just after running the first one by saying exit and give it a status message or a return of 0. You know, it's an integer. The function returns an integer, then close it. So with what we've done here, exit, it is not going to run the next line anymore. I love C programming. It will jump out of it. And to use the exit, you have to import a new header file called standard library. Okay, so that one is stdlibh. Don't worry if this feels too much, don't worry. I just want you to see that we can also, there's also another statement we can use called the return. So I'm going to save this. I just want you to see how it works. I'm going to delete it. We may not use it much. So now that I've used the exit, let's run it again. So let's recompile. I just recompiled, and now let's run our program. And as you can see, hello world ran. Why? Because we said after running hello world, exit, don't do anything anymore. All right, so let's go back to what we are supposed to do. We are going to be talking about GCC. Now GCC helps us in compilation, and compilation is the translation of the source code. Remember we said that the machine cannot understand what you have written. So the GCC is going to help us with the compilation of the source code to what the computer can understand, and that is the object code. So the source code will be transcribed into or compiled into an object code sequence of statements in machine language by a compiler, and this is what the computer understands. And now for this entire compilation process to go on, that is, anytime we do gcc hello.c, 4 steps are being taken. Though it looks very fast, but 4 steps are being taken, and the 4 steps are itemized here. The first step is preprocessing, the second step is compiling, the third step is assembling, and the fourth step is linking. So let's work with the first step. And remember, I told you the compiler we are using is called GCC, which stands for GNU Compiler Collection. Now, preprocessing, the first step in the compilation process. For preprocessing, what shit, I still can't pronounce it properly. The preprocessor has several roles, and the first one is it gets rid of all the comments. Remember, we have some comments in our file. Let me clear this. Remember, we have a comment in our file. So the preprocessor removes the comments. It also includes the code of the header. Remember the header, standard input and output. So it includes the code, okay, because the header has this extension .h, so it includes it. Then it also replaces all the macros. So in order to stop the compilation at the preprocessing step, we need to do this gcc/e. We use this flag. So let's stop our program from compiling completely. Let's stop it at the first step, and the step is called the preprocessing step. Come on, precious. So we say gcc/e hello.c. So we want to see what happens at the first stage of compilation. So enter. But we don't want this on our screen, okay? It's showing on our screen and I can't show you what I want to show you. So let's move it into a file. So let's clear it. We are going to see everything inside a file now. So to move it inside a file, we use the second command, gcc flag e, then the output, the file we want. So let's do that. So gcc, stop at the first step, preprocessing, then output. We want it inside of this file called hello.i. Okay. So we want it inside hello.i file. And which file are we doing that to? The hello.c file. So it has been done, and if we check, we have a new file called hello.i. So let's check what is in hello.i. So vim hello.i. This hello.i file has been stopped at the pre-processing stage. Okay, so let's check it out. Let's see what is inside of that file. And as you can see, like it says, it removes our comments. Can you see that our hello.c file has been changed, and now it has gone in to look for the standard input.output header that we have. Remember, we have that, and now it has done some changes to our file. And after doing that pre-processing, you can see all what we have inside of this file now. So this is what it does before it even gets to the final state. Look, there's so much, and it looks very fast. It has done so much. I wonder when we will get to the bottom. So you see, there is a lot here. So that is the idea. That is what this stage does, okay? So it gets rid of all the comments, then it includes the code for the header file. These are the codes for the header files that you are seeing. So long. This is line 579. And if we keep scrolling, we won't stop. But I'm going to stop there. So that is what you need to understand, that if you want to stop your program at the pre-processing stage, you use flag A, okay? That is the first stage of compilation. Now, the next stage is the compiler stage. So let's exit out of this. Clear. The next stage is the compiling stage. And for us to see what happens here, so the compiler will take the preprocessed file, that is this previous file, and generate an arrow code intermediate representation, and this will create a .s file. So other compilers may produce something else. So this stage is, it converts what we've done in the preprocessing stage and creates an intermediate representation of that file. So let's do that. We use the flag s to get to the compiler stage. So let's go to the compiler stage now. GCC flag capital S, then hello.c. Okay, so we have a new file. So let's check our files, lx. So we have this new file called hello.s. So let's check hello.s out now. This is the compiler stage. vim hello.s. And now the file has been further converted from the preprocessed stage to the compiler stage. Now you can see now that it is compiling it. It tells you the name of the file, hello.c. It tells you the string, hello world, the function name, you see. So you can see that there is more data here, and this is the compiler stage. You see it is shorter. There's nothing much here. It's very short because it's getting to the final stage. So like I said, it's shorter because this is the compiler stage. The file has been moved from the preprocessed stage, and that's what we have here now. So let's exit out of this. So we got here by using the flag s, and we are currently in the compiler stage. But also there is a third stage, and that third stage is called the assembler stage. So the assembler stage, or the assembly stage, it takes the file from the compiler stage, and that is the IRO code, and transforms it into the object code. Remember, the computer understands the object code. So we are now getting to the final step. So it transforms it into the object code, that is the code in which, that is the computer language code binary. So this will produce a file ending in .o. Okay, so for us to stop the compilation at this stage, we use the flag /c. But this file is not human readable. So let's see, /c. Let's check it out. So let's create the assembly code, or the assembler. Let's go to the assembler stage, or the assembly stage. So GCC /hello.c. So let's check the file. So now we have the new file hello.s. So let's check what is inside. Remember, it says that it is not human readable. So let's check it out. vim hello.s. Oh, sorry, not this one. We are working with this hello.o. That is the assembly one. So it ends with 0, with o, sorry, with o. So we are checking hello.o. So you see, it's gibberish. You can't read this. I can't read this. And that's just it. So much. Just 2 lines, but 2 lines of nonsense. To you anyway, to you and I, but to the computer, it makes sense. Let's use less to see it, so we can see how it looks properly. hello.o. So it's telling you now that hello.o may be a binary file. See it anyway. Yes. Can you see? This is the file hello.o. I can't make sense of this. You can't make sense of this. This is assembly language. You don't understand it, but the computer understands it. So you see what has happened. The first file you created, the computer does not understand it. You understand it. But now GCC, or the compiler, has converted our file to an assembly code that you don't understand anymore, but the computer does understand it this time. Okay? So let's clear it. And now there is a final step that we have been carrying out all this while. And the final step is called the linker. So the linker is the last step, and it creates the final executable in binary, and it plays 2 roles. it links all the files together, all the source files, and it links all the function calls with their definition. So you see, what we have been doing has been linking. We've been doing the fourth step before when we do GCC hello. So when you do GCC .hello or main, let's call this hello, GCC hello, it skips all these steps. So if you do this GCC hello.c, it will skip this step. It will do it, but you won't see it. It will do the preprocessing, the compiling, the assembly, and just come down here, everything once and for all. But what we've done now is we've broken down the steps. So if we now run it, that is when we have this file. You know, we always have this a.out file when we do this. But I think it is good practice. It is good practice for us to always ensure that we can give our file any name that we want. So let's go into the program. So previously, when we do this hello.c, this is the linkage step. It does everything once and for all, and it gives us a file called what? a.out. But like I just told you, we can change the name of the file. So instead of having a.out every time, we can actually decide on what name we want the output to be. So we do that by saying GCC, the file we want to compile, hello.c, then the output file. So let's call this hello. Let's call it out. And let's do ls. And as you can see, we have hello.out. So we've changed the name. So normally, if we do this GCC hello.c, we will get a.out. But instead, we did GCC hello.c output hello.out, and now we have hello.out. And let's run hello.out. Hello.out. And as you can see, the same thing, hello world. And let's check our file again and recompile it. So vim hello.c. So I'm going to delete this line, and I'm going to delete the exit. So we'll leave it as it is. Then we save, exit. Let's recompile again. GCC hello.c into hello.out file. Let's rerun it. And you see, it works perfectly. So now you understand GCC compiling and the compilation step in C programming. Now let's move to the next one. And the next one will be what? Variables. So guys, let's begin. So variables. What are variables in C programming language? Variables are allocated space in memory. They refer to a variable to access the value that is stored. That is to say, you can access a variable and it gives you access to the value that is stored inside of it. For you to declare a variable in C, you have to declare the data type first. So you have some gibberish on your screen right now. It doesn't make sense. So what do you think? Let's make it make sense. So let's go to our editor, or sorry, the terminal. And I'm going to clean this, so clear. And let's clean up our folder. So let's delete some of the files. So I want to take out the a.out. Okay, so a.out should go. Then I want to remove the guys with the I, O, and S file. Hello.I. If I do it wrongly, I may delete our main working file. Hello.O. Hello.S. Okay. So let's clear this and let's create a new file called variable. So instead of doing touch whatever, I'm just going to open it directly. So we'll save it immediately. So vim variables.c. Always put your extension C. And every time you start a new file in anytime you start a new file, you have to always include your header. So include, I'm typing this again so that you can always follow io.h standard input output. Then we can just create our comment. We can say, we can call it maybe define name variables. We'll have a main, entry points, return 0 if true. Okay, so let's create our function. Remember, everything we do in C must be inside of the main function. It's an empty function. It's not taking any value, but it is going to return an integer for us if everything we ask it to do returns true. Okay, so this is the skeleton. Now let's begin. So I told you variable is the space where you store information, right? To write a variable in C, there are two ways. The first way is you can declare the variable first. So let's say int x, and this is called declaration. I just declared the variable. After declaring it, I can now initialize it by saying x is equals to 45. And this is called initialization. But easily, you can do both together by saying int y is equal to 70. And what have we done here? We just did declaration and initialization at the same time. Okay? But let's make it practical. So I'm going to do something. Let's create some series of variables. And the first one we should create is, let's create a variable for name. So in C, for you to write names, to write strings, you have to put them inside of an array. Don't worry if you don't know what this is now. Just know that if you want to write a string, this is what you do. We'll talk about arrays in subsequent videos. So I would say Precious, because that's my name, Irieho. Okay. Now what if I'm setting variables? So the first variable I just set is the variable name, okay, which is a character, is an array of strings of characters, sorry. Now the next one is, so it's an array of character. The next one is age. So age will be a number, right? So int, so it will be an integer, and let's call this age. Okay, so you set the data type before the variable name. Don't worry, we'll talk about data types too. It's equal to, so I'm going to give myself a fake age. I'll call myself let's say 200 years old. So you don't need to put the quotes like you have in string. I did not put the ending quotes, you see, first error. So you don't need quotes when you are working with numbers. Then also there's another data type called floats, which is a floating point number that it works with decimals. So let's call this GPA, grade point average, for those who have gone to college or the university. I'll call this 5.00. okay, because it has points or decimal point, that is why we use float for it. Then the last one we will use is a char. It's also a character, but it's a single character, and I'll call this grade. So for single character, you use the single quotes, okay, not double quotes like in string. So I'll call this A. And what have we done here? I just created 4 variables, okay, with their data types and their value. So this is the data type, this is the name, and this is the value. And the equal to sign here is for assigning, okay. Now let's see if we can print out these values. So to print out the values respectively, we do something like this: printf. Remember, the printf is working with what? The standard inputs and output header. That's why we can use the printf. Okay, so printf, and I will say something like hello precious. Now something funny happens here. If I want to access this variable to put it inside of this printf, I'm going to use what is called a format specifier. Don't worry, I'm going to touch on format specifier, okay? Or let's see if we can do it now. So format specifier, no, I'll do it with data type. But for string, the format specifier is s, okay? So when you do that, hello s, then you put the variable that will replace s. And what variable is that? The variable called name. All right? So the variable called name, then we close it. But let me put this in a new line. So new line character. So let's create more printf for the other guys. So printf, let's say age is, and what do we have here? For the format specifier for integer, we use %d. Okay? So, and what do we want to show in place of %d? We want to show age. The next printf is for our GPA. Let's say you scored and what do we want to show for that? Float. The format specifier for float is %f. And what do we want to show there? We want to show GPA. So you scored %f. So GPA will replace %f. That is the value of GPA, which is 5.0, will replace %f here. So you scored. So let's put GPA. No, let me not put that so it won't be confusing. You scored 5.00. Then the last one is another printf so that we can print out the grade. Printf. Let's say your grade is, and what do we want to show there? We want to show the character. So the format specifier for character is %c. So and what do we want to replace that with? With grade. We end it. So let me put new line so that we have everything on one line each. New line. So I'm putting it in front of the format specifier, new line, and new line. So let's run through it again. So what I've done is I'm trying to print out the values of the variables. So the first one is hello %s. %s is for character, is for string, okay, array of string. That is why I use s, and that is the value that will be there will be my name. The next one for age. Age is an integer. So format specifier for integer is %d. So d will be replaced by the value of age, which is 200. Okay? And same with float, which is %f, will be replaced by GPA. And %c, that is the format specifier for character, will be replaced by grade. So let's save this and let's see if our code runs truly. So we have to compile it. So we are compiling what file? Variables. And we want the output to be in a file called variables. You can call it anything, okay? I will just use, let me use exe this time. So variables.exe. So you know that you can use different extensions or file names. And let's check if we have that file. So you see now we have variables.exe, which is the compilation of variables.c. The computer does not understand this one that I created. So we have to compile to the one the computer can understand. So let's run the one the computer can understand and see if we get our output. So dot. So dot means this current folder, variables.exe. All right. And as you can see, hello, precious Ireo, age is 200, you scored 5.00, your grade is A. Okay, now let's edit that file and do some even more changes. So I think there's a problem with the one for GPA, so let's fix it. Okay. So the issue was from here. Age is, take this out, you scored, okay. Now, let's create a better printf. Let's use everything in one sentence. So let's do something like printf, okay. So I will say, now I've gotten my report, so I want to tell somebody about it. I would say, my name is, and what will replace my name? The format specifier for string. My name is %s. I am how many years old? We will replace it with the one for integer. D, I am years old. I scored what? %f for the float. I scored 5.00, which is also the grade. And what will replace that? The grade what? The character %c, which is also the grade C. Now we have to arrange them the way the format specifiers appear. So which one is the first one? %s, which is for character, strings of character, and that is name. So we'll say name, comma. And the next one is, there's no wrap here, sorry. So the next one is what? D, which is integer, age, and the next one is GPA. So age, GPA, and grade. So let's put all that behind. So the next one is age and GPA, and last but not the least, we have our grade. So you see, we've been able to use it all in one sentence. That is what I wanted you to see. Then we can close out, save, and exit. But before I recompile, let's use less to see it so that you will see it properly. You see what I have done. Variables.c. So you see what I have done using less. So I said printf, my name is this, I am this years old, I scored this, which is this. Then I'm replacing them in the same arrangement. Okay, so take note. You can pause this video to look at this and redo it on your own. So now let's compile this. So we are going to recompile it to the same file. So we overwrite it. GCC variables.c. We are compiling this file to variables.exe. And it has been compiled. So let's rerun it. .variables.exe. And let's see what we have on our screen. And as you can see, it has run properly. So your grade is, which is also A, all right? Well, that's because there's no new line here. So let me just fix that quickly. So because there's no new line here, that is why our P is not showing on the new line. So let's do that here. Escape. Save, exit, and let's recompile. Successfully recompiled. Now let's run it. And there you have it. Hello, precious Ireo. Age is 200. You scored your grade is. And now I used it all in a sentence. My name is Precious Serial. I am 200 years old. I scored 5.000, which is also the grade A. Okay, so guys, that is that on variables. You can now see how to declare a variable, initialize a variable. You can also declare and initialize, and you've seen how to set new variables using different data types, and also how to use your variables inside of printf. So guys, I'll see you in the next one. Let's do this. Let's proceed. So format specifier, you've seen it already in our last video with variables. What are format specifiers? They are used within a printf statement, and they define and format a type of data to be displayed. So without much ado, let's get to it. So repeat, a format specifier defines and formats the kind of value that is being shown through using the printf statement. So let's create a file called format. So let's say specifier.c, and let's create everything we need. So the first thing first is our header. Always don't forget your header. Include standard input and output header. Then I will leave the comment out this time because we don't have, or let me put the comment so that you would always put it yourself. I will just say this is a long comment, so you can put a lot of information up there. Now let's create our function, your very important function. You must always create this function and ensure that you return 0. You can return other numbers too, but depending on what you want, but we'll return 0 for these. So like we said, format specifiers are used to format the data that has been sent into the printf statement, and it decides what should be shown. So the first one you need to know, and you've seen already, is for string. S, this is for string. Okay, so this is for string, array of characters. I'm using a comment to hide them from being displayed. Okay, but I know you can see it. The next one is, if you have a character, you use this one for character. Okay, and for integer we use D or I, but most times I like to use D for integer. We also have this for float, format specifier for float. Okay, and we also have LF for long float, which is called double. Okay, so you know the difference between double and floats is actually in the sizes of numbers or bytes that they can store. So a double is more precise than a float. So let's put the format specifier to work, right? So let's create some quick variables. Let's assume we have a store that sells clothes, shoes and bags. So shoes, and we have our price for shoes, maybe something like $65.78. Always put your integer type before you declare your variable. Then for bags, we sell bags for $85.09. Then let's say we sell shirts, floats, shirts at 53.64. Now let's print all this out. Okay, so printf, we will say something like shoes costs, so $. Then how do we show this variable for shoe? We use the format specifier first, f, then we want a new line. Okay, shoe costs what? Let's put a semicolon. Shoe costs that. Then the variable we want to show there is shoes. All right, then we close this statement. So let's do the same thing for bags and shirts. But you see I made an error here. It's supposed to be printf. Okay, so printf, and we will say bags costs in dollars, same thing, float /n and bags. And the next one is, the last one is printf. We're doing this for shirts. Shirts costs $. Then the format specifier, which is also a float. Then that's a new line too. And this is for shirts. Take note of the way I write the codes. Okay, so good. Now we can display these values, right? And let's display it. Okay, let's display it. So we'll save, then we compile this GCC specifier into what output. Let's call the specifier.out. Is an O, not 0. Okay, now let's run it. Specifier.out. Now you can see that we have our values, but then these are not what I typed in, if you check correctly. Okay, let me do a cat of specifier.c. So if you see, I did not type 99999, but then see, it brought them out. I stopped at 08, and now we have 999 at the back. So what is happening now is that it is working with the precisions. Okay, so to fix this, we can go back there and use precision vim. Okay, so for us to change the way it prints out the results, we can ensure that only 2 decimal points is being printed out. And to ensure that 2 decimal points is printed out for the first float, all we do is just say 0.2. Okay, so that is 2 decimal points. You put it after the percentage, 0.2. I'm going to do it for all of them, 0.2. All right, now let's save that. So this is what you call decimal precision. Let me compile it again, then rerun it, and let's see if our result is proper now. And now you can see it is respecting the decimal precision that we just applied. We said 0.2, that is 2 decimal point, and as you can see, 1, 2. All the other extraneous data has been taken out. Okay, now not just that, we can also decide on the minimum field length, field width, and the left align. And how do we do that? The field width, we decide the number of widths, or how long we want the characters to be. So let's try that. So I'll say vim specifier.c, and for the first one I will leave it as it is. Then the second one I will apply what we call the field width, and I will say 10. So we want 10 field width, and for this one too we want 10, but we want to align it to the left. So for aligning you use minus. So take note, the first one we've used a decimal precision of 0.2. The second one we use a field length of what? We use a field length, a minimum field width of 10, and for this we use a line of -10. So in case you're wondering what is happening, what I've just done is I'm applying decimal precision. Okay, so this is decimal precision here. It helps you to format your data more. So what I did was 0.1 is 1 decimal precision, or in this case we use 2. Then for field width we use 10, so we say 10 field width. Then when you use a minus 10, you say align 10 fields, align to 10 fields to the left. Okay, so that's what I've just done here. So I've used decimal precision, field width, and align. So let's check how it comes out. So let's compile again. Let's run it. And as you can see, what can you see here? The one we use the 10 field width for has moved to the right. All right. The one we use minus for has moved to the left. And the one we use nothing for is still the way it is. So the reason why this one still looked the same with this was because there is not much space for it to move to the left. So now you understand the format specifiers and how to use the decimal precision to use the field width and the align. So we'll see you in the next one. So guys, this is data types. So data types in C programming are declarations for variables, and they determine the type and size of data associated with a variable. So as you can see on your screen, we have a table that shows the type of data, the sizes, and their format specifiers. So you can see we have int, we have all sorts of format specifiers here, and also you can see the different format specifiers, and you can see their values in sizes, what they can store, and the type of data that they can store. Okay, so let's do this quickly. Let's create a file called data.c. So I've copied some documents. I'll just put this in. I just pasted it because it will take us a long time to type all this out. So I just want you to see that there are different data types in C, and well, you may not use every one of them, but most of them will be used by you. So you see, we have the first one, the character A, C, which is a single character, and the format specifier is %C. Okay, the next one is array of character if you want to show a long string, and here you have it, array of characters, which is a string, is %C. Then you have float and double. You see, the difference between a float and a double is that a float can store 4 bytes or 32 bits precision, while a double can take 8 bytes or 64 bits precision. So it is more, a double is more precise than a float. Then we have boolean, true or false. Okay, it takes 1 byte. These are the sizes, 1 byte, and I had to import stdbool to use boolean here. We also have this char f, which is an ASCII table. So when you use char with a number, it goes to the ASCII table and it gives you the value of that value in alphabet. Okay, so you use %d or %c. So we have others: unsigned char, short h, unsigned short, integer j, int, unsigned int, signed int, long int, unsigned long int. So you see, there's a lot of them. All right, there's a lot of them that we can use, and the most important thing is for you to understand that you can be flexible as much as you want. So let's just check. We've been able to print out the values already using variables, and maybe I want to show you something else called size of. So let me comment some of these guys out. Because if I don't, it's going to mess with our code. So I'm commenting them out so that we can do some stuff. I want to show you something, how you can check the size of a variable and also of a data type. So let's do it for char. So we have character A, which is which has the value of C. Okay, so let's print it out here. Let's use this. So this is it. Then we say size of A. Remember, A is what is storing the value, right? Size of A is equal to format specifier of D, you know, that's a number, and size of char is equal to format specifier of D, so that's a number. So now we want to check the first one, size of. So you can check the size of a variable, and that is the variable A. And we also want to check what? We want to check the size of the data type, what? Char. Okay, guys. So let's see what this prints out for us. So I'm going to compile this now. GCC data.c output. I want it to be data.exe. Data.exe. Okay, so let's see what the problem is. Let's see if it was compiled. Sometimes it compiled with error, so I know the error will be there, but I wanted you to just see this. So lx, so we have it. So let's clear, ignore the error. I just want you to see something. So data.exe, and as you can see, the variable is C, and the size of A is 1. The size of the data type character is 1. So let's do something for the next one, string, before we close this. Okay, so let's comment this out and do it for string. So let's do this for string. Okay, so the variable name is B. So we turn this to S. Size of S, or B, sorry. Size of B and size of char. Okay, all right. So let's go out of this. Let's recompile this. Clear, ignore the error. And as you can see, it says precious area, size of B is 18 and size of character is 1. So if I count everything here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Then the invisible character there, it makes everything 18. So you see, one character is 1, but in total it is 18. So I know I'm not supposed to have done this with this big file. That is why we have the errors popping out from everywhere. But I just wanted you to see the sizes of the data types and how to verify them. So just to make it easier, we could do something. So let me exit out of this. Okay, so data So let me clear that file, data.c. All right. Then let's check one of the data types. So we have different sizes. We can check the size of floats, which is supposed to be, so you see what we have before. Character is 1. Let's check for float and double before we close this video. So let's check for float and double. All right. So let's edit. So include stdio.h, and I'm not going to put the comments. I just want to do this quickly. So we are returning 0. Then let's print. Let's just do a printf. Format specifier of integer. Let's just say size of floats. Okay, and that will be size of floats and the next one is printf size of double data type. Because size of is a number, okay, that's why we are using the integer specifier, okay, of double data type. So let's just print this out and see what it shows us, okay? So on your own, you can add the other data types to check their different sizes. So let me compile this. Let's see where the error is. Okay. So the error is here, semicolon, I use that. And also, just to prevent more shouting, let's just declare some variables. Let's call this floats x and double y. It's good that you can see me making errors so that you can avoid it. I have a wrong spelling already. Floats, good. So let's clear. Let's recompile. And let's see what the issue is again. My bracket is missing, guys. My bracket is missing. Ow, I don't know. It's missing. So let's save this again. Let's clear. I don't like errors. But as a programmer, you should be ready to debug. What is it? There's something wrong with the size of, because if we check, the data is out, okay? So size of a double is 4. Let's clear that up. Let's clean it up. So by just using new line, So that's new line there. So let's return and check this out. Okay, so let's save this. And let's clear. So I think these errors are showing because we are really working on the terminal, but naturally, so it's just a warning. It doesn't mean it won't work. It's telling us that the D we are using shouldn't be used. So let's try the other format specifier. You know, I told you we can also use I. So let's try I, since we've not even used I at all. So let's try I. So D and I, they do the same thing. Okay, so clear. So it's not an error, it's just a warning, but it's the program still runs. So I is int, it's telling us it wants a long integer. We're not doing long integer here. So now let's do that. Let's check the data type and let's see the size. And as you can see, size of a float is 4, size of a double is 8. So size of a float is 4, size of a double is 8. And if we check it here, size of a float is 4, size of a double is 8. But I don't like these errors on the screen. These warnings, they are not errors, they are warnings. So that you know that there's really nothing wrong. So let's try to just fix it. So let's give it the format specifier for long integer. Maybe it will be happy, li. Li is on the table and it's on the format int data types I showed you. So it's nothing new. This is for long integer. Okay, save. So let's clear and let's compile. So you see the error is gone. It wants a long integer because of the value. And let's rerun this now. Data, not error, warning. And as you can see, size of a float is 4, size of a double is 8. So that's it on data types, and also that is it on how to see the size of data type. So to see the size, you use the function size of. Okay. Now, the next thing I want to talk about is constants before we close this. So constants are fixed values that cannot be altered by the program during execution. So you have to precede the data type of variables with const and write the name in opposite. So if you have a data type that you don't want the name to change, all you need to do is to turn it to a constant. Do you know why that is? Let's use our data table, data file. You see, I have a variable here, which is a float x. And let's say float s is equal to 34.6. If I go ahead, okay, if I go ahead to create another variable called float x, and I call this 78.9, you can already guess what will happen. What will happen is this. The second one will precede over the first one. So let's try it. So we say x is equal to s is equal to format specifier for floats. Okay, we don't want the size anymore, and we put what? We put x here. So we want to get the value of x. Okay, take notes. Previously we had 34.6, but because it is not a constant, if we set the variable again, the value will be reassigned. So we will now print out 78. So let's check it. So you will see the importance of a constant now, why you should use constants. So let's do this. What is that? Let's go back in there and see where the problem is. So float x is this. Okay, there shouldn't be any error. Let's try that again. Okay, so you see, it is already telling us that error, redefinition of s float x, data, previous definition of x was here. But let's see if we can get the value out. Oh, so we've not been able to, it didn't execute. So clear. So what I want you to see is that we can reassign the values of variable. So let's do that properly. So we don't need to redeclare. So what is happening is I'm redeclaring. Since we've declared it, we can just say x only, okay? We can now say x only because x has been declared already. Let's compile. Now it has been compiled, and let's see what is the new value of x. What will it print out? And you see, it printed out the second one, 78.9. Why? Because the value of s, the value of s has changed. Let me use cat so you see it. So you see, we had x before as 34.6, but now x is now 78.9. So the value of x has changed. So you use constant when you have values that you don't want their values to change. So and how do we do that? We go in and say, in front of these floats, you put what? You put const. Okay? Then it is good to always put the variable name in capital letters. So we can use something like pi. Let's use pi. Since pi is a constant in mathematics, it's 3 points. I think 142 or 146. Let's do 3.14. And now let's try to redeclare it. So we've set it as a constant. Let's see if the value will be changed or it will remain the same. So let's compile it. So as you can see, there's an error. It won't work. You know why? It says const undeclared, first used in this function. So we can't redeclare, and now it's throwing an error. It's throwing an error because we've declared it as a constant. And when you declare it as a constant, that's wrong. So we're supposed to do this as pi. So we try to redeclare the value, okay? I won't edit these errors out so that you will see why I made them and you won't make them too. So now you see, now let's compile it. I have to be calm, man. So we have to change this to, so pi, and this is what? This should be pi, okay? That's the problem. So I think we fixed that already now. So let's clear, let's redeclare again, let's recompile. So you can see. So let's redo the file. So const is supposed to be in small letters. It's the variable name that should be in capital letter. Okay. So const, good. Now let's save. Now let's compile. So you see, the error says assignment of read-only variable pi. That means we cannot reassign pi because pi has been assigned already. So that is why you use const. You use const when you want to set a variable that will not change for the lifetime of your program or as long as your program runs. So see you in the next one. Hello guys. So this is input and output. Input means to feed some data into the program. An input can be given in the form of a file or from the command line. Now, C programming provides us with some inbuilt functions, some set of them, to read given input and feed it to the program as per requirement. And when we say output, it means to display some data on the screen. So the first one we put to use is getchar and putchar functions. And what they do is they help us to take in inputs of single character, just one character. Okay, so let's put it to action. So let's create a file called vim user.io, user input and output.c. Then let's do our thing. We import the header, so we include the standard input output header. Then, like I told you, your comments are important, so we'll just say input and output. You can always make this better. I just want this to do this quickly for the sake of time. Now let's create our function. So int main, remember all your C program must have the main function. And you return 0. So we want to use getchar and putchar, which helps us with one character. Okay, so the first thing we do is let's declare a variable called C, variable C. And now that we've declared it, we can use it. So let's use printf to prompt the user. Okay, so printf, and we'll say enter a character. All right, so we're telling the person to enter just a character. Then we use getchar to set the input so that we can collect the character from the person. Getchar. Then after the person has entered the character, we will use putchar to return it to the user. So you use getchar to collect and you use putchar to return. Getchar is for input, putchar is for output. So printf, we'll say something like you entered let's say you entered this, let's put that semicolon. So let's put a new line so that everything falls on a new line from here. Then we can now use putchar here. Putchar C. So let me explain what is happening. So what has happened now is we set a variable int. Okay, we set a variable int, then we tell the person to enter a character. Then we use getchar to collect the user input and assign it to the variable C. And when we tell the person to print, we also use putchar to bring back what is in the variable C. So let's see it in action. So I'm going to compile this user.io.c and let's compile it to user.io.out. Let's use out this time. Okay, we have an error. I always forget my semicolons. Guys, don't forget your semicolons, please. Sometimes it's easier to debug when the program is not long, but when the program becomes long, it becomes a serious issue. So let's clear and let me redo it. So let me compile it again. I think we have another issue. And where's the problem now? So getchar I, int main, enter a character, getchar, printf. You entered. I think we should be fine. I think we should be fine. We are not fine. Let's check what it is. So we did not close it, like you said, like I told you, no semicolon here too. So we always have to ensure that we close all our statements. If not, there will always be errors. So let's recompile and see if it works this time. So it worked. We've compiled now. So let me clear the screen before we get our outputs. So now let's do the outputs. So now it's telling us to enter a character. So I'm going to enter arrow. And as you can see, it says you entered arrow. Okay? I know it's not looking pretty. So let's see if we can do something about that. Okay. So enter a character. So let's print a new line here. And let's print a new line here too. Let's print 2 lines. And let's print a line here too. Okay, I think that works for us now. So let's redo it. So let's recompile. I use print. I still love to use print. So it should be printf, not print. Printf, 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 printf. In C, it is printf. So it has compiled. So let's clear. And let's check it out. Good. It's working properly now. So enter a character. I'm going to enter G. Okay? And you see, you enter G. Let's run it again. Let's try numbers. Let me enter 65. You enter 6. You see, it's working the way we expect it. It can only take 1 character. Okay? 1 character. Let me put 2 characters. DF. Can you see? It's only taking 1. It can only take 1. So that is why if you want to get only 1 character or print only 1 character from the inputs or send only 1 character to the outputs, you can use getchar and putchar. But what if you want to get more from the user? Then we can use scanf. So let's see scanf in action. So scanf in action. So using scanf, let's rework our current file so that we can take more inputs from the user. So let's clear this. And let's edit our user. Let's edit this file. We are working with this file. So let's make the application better. So let's say we are collecting age and name. First name. So F name. Now let's collect the person's name. So enter your first name. You will know why it is first name now. Then we delete this. So for scanf, you say scanf, then you use the format specifier. So we are taking for fname is a character, so we are using format specifier for string. Okay, and what are we taking? We are taking fname, variable fname, so it will store it there. Then for the next one, we are taking, let's leave this print so that we have space. So now we also want to take what? We want to take the person's age. Okay, enter your first name, enter your age. Okay, and we do another scanf to collect age. Scanf, format specifier, because age is an integer, so we use %d age, and now we can print the results. Okay, so let's make it look pretty. So we can do something like hello. So we say printf hello, so the person's name, format specifier for string, you are, so format specifier for integer is d. So hello, you are years old and allowed to enter. So now what variables are we changing in the right order? The first one is fname and the other one is age. So we close this. But now I want you to take note of something. To print this age, we have to use something called the memory address. It's AND. So the memory address is where this variable is stored. We will talk about this in another video, but for now just understand that if you want to print the value of an integer with scanf, you have to put the memory address. But for string, you don't have to do it, because the string is an array of characters and is already pointing to the memory address. So let's try our little application out again. Take note of the code. If you are typing along with me, take note that you don't make any error like I've been doing. So let's save this and let's compile. So we have an issue. We did not set the size of an array. So something else you should also take note, you can set the number of values you want to take for your array. So let's say we want to take 100 characters, okay? So I'll just put 100 here. That is the issue we have. So for your array of string, you set in the numbers of characters you want to take. So look at it once more before I save, then we'll run this code. So let's recompile. The code has been compiled. Now let's run it. So enter your first name. My first name is Precious. So enter age. My age is 100. I didn't put a new line there. And as you can see, it says, hello Precious, you are 100 years old and allowed to enter. Let's make this look good. So new line, and finally new line here. Okay, so let's redo this. Let's clear, let's recompile, and let's run. So enter your first name. First name is Precious. Enter your age. Age is 180. And as you can see, it says, hello Precious, you are 180 years old and allowed to enter. Sorry, allowed is spelled incorrectly. Now, what if we do something? what if we enter more than one character? Okay, what if I enter my full name, Precious Ariel? You see, the scripts break. Why? Because we are not allowed, it cannot take more than, it can't take, anytime if scanf sees a space, the scripts end. You understand? So scanf does not work with space. You cannot put space when you're using scanf. Alright, you can't use space when you're using scanf. So instead of space, you can only take in characters. Anywhere, if it meets a new space, it will break out of it. That is what happened. Because of this space here, it broke out of our code. And as you can see, it says hello Precious. It didn't even take the other one, Ariel. It only took Precious. Then the code was not executed. So if you're going to be having space in between your characters, you cannot use scanf. So let's rerun it again. If you want to use only one character, if you are using only one character, like A, B, C, 1, 2, 3, only one, you can use getchar and putchar. If you want to use characters, a lot of characters, you know, like a full name, but there should be no space in between, you can use scanf. Alright. But when you now want to take characters that have space, okay, that is when you use gets or fgets. Alright. So, but before that, let's check something with scan. So, scanf can also take multiple inputs. So let's just do that quickly. So we can have multiple inputs for scanf. All you need to do is just to specify the new formats, okay? So that issue we had with our f name, we can solve it with scanf too, though it's not a good one. So we can do char l name 100 and we can just add it here and say, so that one will be l name, and we can come down here and print it properly. But this is not a good way to go about it, but it's just hacking the system. S, then we have l name here, and let me correct this spelling error. So good, let me clear this out and let's compile and let's run our script. So enter your first name, so we'll say Precious, and it wants to take the second name, okay, because now we say it should collect two values. So Ariel, and now it can go to age 170, and now you can see that I've been able to hack it. So hello Precious Ariel, you are 170 years old and allowed to enter. Okay, so this is one way to do it, and this is scanf. The next one we will be checking out now is, so the next one we'll be checking out now, as you can see, we've been able to do this. So the next one we'll check out now is the fgets. So let's try the other way to do this. So clear. And the other way to do this is to use gets, fgets and puts. So let's do fgets and puts first, then I will tell you how to use fgets. Okay, so let's begin. Let's edit our file, and I will make this one very short. Okay, so we want to collect the first name, or let's call this full name, okay, because we can do it now. We can take the full name now. Now let's tell the person to enter their full name. Enter full name. And when they enter the full name, we will use gets to collect the full name, okay? So we are collecting the full name with gets. And I'm printing a new line, so that's a new line in between. Then what do? We can now print out the name back to the person. So we say your full name is, your full name is, so put. So I'm going to change this from scanf to put. All right. Then we are returning the string back. So we can delete the lines we are not using. Okay. So look at it again. We are using character full name, right? Then we say enter your full name. Then we use gets to collect the full name. Then we are printing a new line so that there will be a space. Then we now print back the name to the person. So we say your full name is put str. So something about puts. You can use puts to also print back to the screen. So let me just print something else to the screen. It's not by collecting the data too. So I can do something like I was printed back to the output too. So it's not only what you put into puts, you understand? It's not only what you put into the input, you can also put something with puts and you can have it on the screen too. So this should show on our screen. So this is it. Printf, enter your full name. Then we use gets to collect the full name of the person with space or anyhow you want to put it. Then a space in between. Then printf, your full name is. Then we use puts to print back the results, what the person entered, back to the person, which is not str, which is full name. They entered full name. Then also we are using puts to print out a value that was not entered before. Okay, so now let's print this out. First, let's compile. So this is where I wanted to bring to your notice. It is a warning, but we'll correct this shortly. But let's see if our function runs. So it's saying using gets is dangerous and should not be used. Take note, you shouldn't use gets anymore. We'll correct it now. But let's just see it in practice. So enter your full name. I will enter my full name, Precious Ogenahogie Irieho. And as you can see, it says your full name is Precious Ogenahogie Irieho. And what the other stuff we put there was printed back to the output. So you see, but we are using gets and the system is warning us. It said don't use gets because get is dangerous. So what can we use? We use this guy, fgets. So let's use fgets. So let's go back in there and let's comment gets out. Since we're not using it anymore, the computer say gets is dangerous. That's what C is telling us. So instead, we use what we call fgets. So fgets as a function takes in 3 parameters. The first parameters is the variable name. Okay. The second one is the length. So 100. Since we are using 100 here, we can use 100 here too. And it's last but not the least is standard input. So you tell it that it is a standard input. Then we close this, and that's the only change we need to make. Take note of the other scripts. So we still have our puts full name and puts that was printed back to the screen. And let's do something else. Let's do another put. So we'll say, for this one we will say puts get was changed to fgets, and that's what we did. So close. Okay, so we can save this now, and let's compile. Compiled successfully. Now let's run it. Let's recompile. So you see it was successful. Now let's run it. Enter your full name, Precious. You see, even with all the space, it doesn't matter anymore. I have a lot of space and it doesn't matter. It takes it. And as you can see, it says your full name is Precious. Okay, now I can get area. I was printed back to the output too. Get was changed to fget. So you see, guys, that is it. 3 ways to take input and output in C: getchar and putchar, scanf and printf, get, fgets, and put. So guys, I'll see you in the next one. Thank you. So guys, currently we are on operators. And what are operators? An operator is a symbol that operates on a value or variable. For example, plus is an operator to perform addition. Like you can see, C has a wide range of operators to perform various operations. So let's check the first one. The first one is the arithmetic operators. And we have the operator plus, which is addition or unary plus, minus, subtraction or unary minus, times or multiplication. Then you have the division, the remainder after division called modulo. So let's check this out. So let's clear what we have on our screen from our last class, and let's create a new file called operator.c. So what I've done is I've copied this already. I typed it to save time. So I've pasted it. I'm going to talk us through it. So as you can see, I created some variables separated by comma, or you can put them on new line. Okay. So if you have them all on a new line by comma, you don't need to declare. So they all have the same type, separated by comma. So C does not have a value, is empty. So now let's check it out. So what we are doing is, for the first one, we did addition. A plus B, and we print out the results. A minus B, and we print out the results, and that and that and that. So what we are trying to do is we are trying to see all the operators at work. Take note of this one, modulus. Modulus, or this percentage, is remainder when A is divided by B. So it's called modulo, remainder. Okay. So let's check the result of this out. So you can do it. It's just simple addition and subtraction. That is why I don't have to type it, so that we can save time and we can move very quick in this video. Okay, so let's save and let's compile. GCC operator output operator dot, let's use out, operator dot c. Okay, good. So let me clear before we run it. Operator dot out, and as you can see, our addition operator has done its work. So you see, A plus B is 13, A minus B is 15. So let me do cat so that we can see what is inside the file, the folder, before we did all that. So you can see A plus B is 9 plus 4, 13. A minus B is 9 minus 4, 5. Yes. A times B is 9 times 5, 36. Or 9 times 4, 36. A divided by B is equals to 2. Okay. It's 2. We didn't make it a float, that is why we have this issue. But if you turn it to a float, so you type int, there is something called type inting. If we type int it, we will get the proper value with points. But because it's just an integer, it's printing only the integer value. Then remainder divided, when 9 is divided by 4 is 1. Okay, so 4 will go into 9 2 times, remainder 1, and that is arithmetic operators. Now let's check the other operators. The next operator is the assignment operators. So let's check it out in the terminal. But before we check it out on the terminal, I think we have increment and decrement operators. So let's do that first. So increment and decrement operators. So let's clear our screen. And let's edit our file. So I'm deleting everything because I already copied what I want to use. So paste. Now, what we are trying to do here is called increment and decrement. So we are incrementing by 1 or decrementing by 1. So when you have plus plus before a value, it means add 1 to it, okay? And when you have plus plus minus minus, it means subtract. It's as simple as that. Minus 1 plus 1 when you have it before or even after. So let's just check it out. So this is increment and decrement. So this one is incrementing plus plus a, and minus minus b is decrementing. So let's check them out. Let's compile and let's run and let's cut. So you can see we incremented a was 10 before, then we incremented it plus plus a, so it means plus 1, okay? That's why you have this. Same thing with b, it was 100 minus minus 1, minus minus 100 minus 1, and that's how you have 99. So same thing. So when you have plus plus or minus minus, it means 1, 1, add 1 or minus 1. So that's it on increment and decrement. Now let's go back to the previous one we want to talk about. So we want to talk about the assignment operators. And here you can see already, assignment operator is useful to shorten the numbers of typing or codes you need to do. So plus is equals to is still the same thing as a plus b, okay? And minus equal to is still equals to a is equals to a minus b. So let's just check this out. So we go to the terminal. Clear. Let me make that file empty. Operator. So I want to make it empty. Good. So we can go back into it. And now let's drop this. So this is our what's it called? Assignment operators. So we've set integer a to be 5 and c to be nothing. So now c is equal to 5 currently. Now when you have this, when you have c is equals to a plus a, it's still the same thing as saying c is equals to c plus a, and you know that already, that is 10. Same thing with this, is still the same thing as saying c is equal to c minus a, okay? So because c is 10 here already, so 10 minus 5 is equals to 5, okay? C is now 5. Now when you come down here and you say c is equals to, it's still the same thing as c times 5 times a, okay? A is 5 and c is currently 5, so 5 times 5 is 35. So same thing is, now c is 25, so it's equals to c divided by a, c divided by 5, and it's 5. And when you come down here, modulus is still the same thing as c is equals to c modulus a, that is 5 divided by 5, and that is why you have 0, because when 5 divide 5, the remainder is 0. So let's try it out on our terminal and let's see what it prints out. So let's compile and let's run, and let's cut it to see that's C. So you can see C was 5 initially, and the operation is actually correct. If you match it, even if you change the value, it will still be the same way. So that is the operator, that is the assignment operator. Instead of saying A is equals to A plus B, you can just say A plus equal to B. Same thing, A minus equal to B, you know, just to save time, actually, to save time. The next operator is the relational operators. Here you have double equal to. So when you have 5 is 5 equal to 3 is not true, so it's 0, is false. Greater than 5 is greater than 3 is true, so it's 1. 5 is less than 3 is false, so it's 0. 5 is not equal to 3 is true, so it's 1. 5 is greater than or equal to 3 is true because it's or, so one of them will be true. Less than or equal to 3 is less than or equal to 3. None of them is true, so it's 0. It's not less than and it's not equal to 3. So let's check it out. So we move to the terminal. Empty the file. This is a trick. Now let's go into the file. So like I said, I already typed everything so that we don't waste time with typing. All we need to do is to look at how they work. So now, I've explained it already, but we can still look at it again. So we have integer A is 5, integer B is 5, and integer C is 10. Using the relational operators, we are checking if 5 is 5 equal to 5. This is true. Okay? Then we are also checking is D. So we are checking is this equal to this. So it's going to print out the various value. We will not see it here. So let's just save and let's go back to the terminal. So let's check it on the terminal. Let me clear this. Let me compile. Then let's run it. Good. Then let me cut. Okay. So you see, 5 is equal to 5 is true. Right? 5 is equal to 10 is not true, so it's 0. 5 is greater than 5 is not true, it's 0. 5 is less than 10. 5 is greater than 10 is not true, it's 0. 5 is less than 5 is not true. 5 is not less than 5, it's only equal to. 5 is less than 10 is true, 1. 5 is not equal to 5 is not true, it's 0. 5 is not equal to 10 is not true, it's 1, is not equal to. 5 is greater than 5 or equal to, yes, it's true. 5 is greater than or equal to 10 is not true. 5 is less than 5 or equal to 5, yes. 5 is equal to 5, so that one is true. 5 is lesser than or equal to 10, 1 is true. 5 is lesser than 10, so that is true. So that is it on relational operators. It just checks if two values matches based on some conditions. All right, so let's check the next one. The next one we have is logical operators. So we have logical AND, which is only true if both operands are true, and logical OR, which is only true if only one or other one is true. And logical NOT changes the value. So if you have true, if you use NOT, it becomes false. It becomes false. So let's see logical operators in action. Take notes: double ampersand, double pipe, and exclamation mark. So first, I'll clear this and empty my file, then open the file and paste all this. So now you can see we are checking if some conditions are true. We can't see it properly here until we run it, so let's run this. Okay, I just compiled it, so now we can run it. And let me do cut so that we can see what we were working with. Good. So we have integer a5, b5, and c10. The first one says a is equal to b and c is greater than b. A is equal to b, which is true. A is equals to 5, but c is greater than b. That is true. So both of this is true, and the result is 1. Okay. The next one, we are using AND again. A is equal to b. This is true. C is less than b. It's not true. So it means since it's only one that is true, and we are using AND, everything will be 0, false. The same thing here. We are using OR. A is equal to this, and A is less than b. This is not true. This is true. But since 1 is true, and if we are using OR, the answer is 1, true. The next one is A is not equal to b. It's not true. A is equal to b, so this is false. C is less than b, that is 5. 10 is less than 5. It's not true. Both of them are not true. So everything here is false, 0. The next one says A is not equal to b. First, look at it. It's twice. Oh. A is not equal to b, 1. A is not equal to b, which is true. Then this one now turns it to what? A is not equal to b, so this is 0. Then when you use this again, it turns it to true. So that's why you have 1 here. And here you have A is equal to b, which is 1. And this one will now turn it to 0. That's why you have 0 here. So that's it, guys. If you really are confused with all this, you can always get across to me in the comment section, in the groups, or in the forums, and I will be there to respond. So that's it, guys, on logical operators. So let's check the next one out. So the next one is called bitwise operators. So bitwise operators works with binary. So you have bitwise AND, bitwise OR, exclusive OR, bitwise complement, shift left, and shift right. So let's check them out. Let's clear our file. Let's open the file. And I already typed them out, so let me paste it. So you can see bitwise operators, they are special operators used in bit level programming. Knowing binary is important for this topic. So even if you don't know binary, you can always go back to learn. So what it does is, we are doing some calculations. So X and Y is going to do all the binary, and it's going to give you the solution. So the first thing first is, for this guy, X and Y, and for AND, 2 has to be true. So 0, 0 will be 0, 1, 0 will be 0, that is AND, 1, 1 will be 1, 0, 1 will be 0, and 0, 0 still 0. For OR, you only need 1 to be correct. So 0, 0, 0 will be 0, 1, 0 will be 1 because 1 is there, 1, 1 will still be 1, 0, 1 will be 1, and 0, 0 because it's all 0. So you see, for OR, 1 has to be correct. 1 has to be confirmed for both to be true. For AND, 2 has to be true. That's why we only have 1, 1 on the third one here. For exclusive OR, you only need to have 1 to be true. So 1, 0, 0, 0, 0, 1, 0, 1, 1, 1, 0, because it's not exclusive. 0, 1, 1 is exclusive. That is for exclusive OR. Now the next one here is shift left. So if you have a value, we have 2, x, this is x, 6. If we shift it left by 2, that is what you have here. Previously it was here. When you shift it left by 2, you will add 2 zeros to the right hand side. That is why we have 2 zeros here. Then we remove 2 zeros from here, and that's why we have this. And for y, to shift right, sorry, this is supposed to be shift right. So shift right. So y shift right. To shift right, you had 2 zeros to the left hand side. So we added 2 zeros here, 1, 2, to push this. So when you had 2 zeros here, 2 0 will leave from the left and right hand side. That's why we have this. So let's print this on our screen and see. So let's compile. We've just compiled, and let's run. So these are binary values. If you convert this to binary, that is why I've done the conversion already. So if I do cat operator, so these are the binary values. So you have 4, 10, and this is 4 in binary, this is 10 in binary, this is 4, 14, 10. So this is 4 in binary, 14 in binary, 10 in binary. And when you shift left, you have 24 in binary. And when you shift right, you have 3 in binary. So just check it out, and it works the same way. You can type this out, and you can always get across to me in the comment section. I'll be waiting. So guys, let's move to the next one. So the next one is going to be math function, and this is going to be the last one for this video, so it doesn't get too long. There will be a part 2 where we'll complete everything on C programming. So in math function, you can carry out some math functions in C, and let's check some of them out. So let me clear this, and let's create a file called maths.c, and I've copied everything, so let's just paste it. So let me walk you through it. For you to use the math function, you have to include the math.header file. You already know what an header file is. It's important because without this header file, you cannot use this math function. And those of us who use math a lot in school, we can remember we have the round, we have the seal, we have the floor. So round is going to round up the number to the nearest whole number. Then seal is going to round up. So when you do seal, you get 5. And floor is going to round down, so you get 3. Square root of 81 is square root, so that's 9. 2 raised to power 4, that is 2 times 2 times 2 times 2 times 2. Then absolute value, so it goes to the, from 0 to make it positive, it goes to the absolute value of minus 100, that is 100. Absolute value of minus 50 is 50. And remember logarithms, so log 3, you get the value. Sine, remember trigonometry, sine 45, cos 45, and tan 45. So guys, let's see if we can output all these results on our terminal. So looks like there's a lot of printf for me. Okay. All right. So let's see how we can get this all out quickly. So I just did a copy and paste so that I can print out all the values easily. So the first one is int a. So that one is an integer, so we change this format specifier to d, and that's a. So the first 3 are integers, so we have int. So let's do that as it is. This is b, and this is c, d, and the other guys are doubles, so we'll leave them as they are and change the alphabets. D, E, F, G, H, I, and J. So let's go to our screen, our terminal. So what we've done is we want to print the results for everything that we have here. All these calculations, we want to print their results. They are all math functions. They are all math functions in C. So let's check out the results. So take note of them. You will use them, especially when you decide to create a calculator or let's say a shopping system. So let's compile this file, GCC maths.c. to what output? Let's output it to okay. Let's call it maths.exe. Good. Now let's run it. .exe. New line, guys. New line. So let's go back into the file and put new line for everything. Okay, so I forgot to do that. I'm sorry, I have to do it now. So new line, so that everything is going to be on a line of its own. That is why we have to always do everything correctly from the beginning. If not, we'll be stressed out doing them again. Okay, I think we're good now. So we have new lines for everything. So let's go back and recompile this, and let's run this again. Okay, good. Now let's do a cat so that we can compare. So you see the first one is 7. So we say round 7.146 and you have the value of 7. Then seal 4.146 is round up. Seal is round up. 4, it took it to 5. Floor 3 point now, round down, it stays at 3. Then we have square root of 81, 9. 2 raised to power 4 is 16. The absolute value of 100 is still 100. Log of 3 is 1.098612. Sine 45 is 0.850904. You can use your calculator if you want. Cos 45 is 52525322, and tan 45 is 1.619777. So guys, that is it on math function. And also, so guys, that is it on math function. So guys, that is it on math function, and that is also it on this video because it's getting too long for us. So in the next videos, we will touch on even more concepts about C, but at least we've been able to touch the basics. So in this video, we've been able to talk from the C programming, and we talked about the introduction, we talked about the tools, we talked about the simple C program, we talked about the compilation process that involves the preprocessing, the compiling, the assembler, and the linker. And we went ahead to talk about variables. We touched on format specifiers, the data types, we talked about constants, user input and output using different methods, 3 different methods. We talked about operators, which includes arithmetic, includes but not only arithmetic operators, assignment operators, relational operators, logical operators, all in C language, and we also stopped at math function. So in the next videos, we will talk about the control, if and else, functions, pointers, and arrays. And for now, guys, I'm so happy that you are here all through and we were able to get through with this. And I'll see you in the part 2 of this C programming tutorials. Precious Ireo out. Thank you, champions.